This is Geometry Lesson 8.3, continuing with area. We're going to look at the area of irregular figures. So the big idea says areas of irregular figures can be estimated by covering the figures with smaller and smaller square grids. Okay, so as you can see in the picture, we're starting off here with what appears to be an island. Okay, so kind of like on a map. And we want to estimate the area, and we're not able to break it up into perfect squares all over that island. So we're going to kind of estimate how much is in each square. You can see we've got one full square. If you flip it over and look at the other ones, we've got smaller and smaller squares. It's the same picture, but smaller and smaller squares. As we get towards our final one, there are more full squares, so we don't have to estimate as much on that one. You'll notice that the scale is the same, right? Because the size of the island is not changing. So while we're going to get different answers, it's only because we're getting more exact with our estimating with the smaller squares than we are with the bigger squares. But each square is going to be worth a different amount based on just how big it is, and we'll be doing that looking at the scale. So when we do this, we're not actually going to get crazy and look at this and say, well, I think that's 0.10 of a square, and this is half, that's 0.5. So we're not even going to get that exact. We are just going to count the number of squares that are inside. So that would be the shaded one right here. We're going to count the number of squares that have some part of the boundary. So that's what B is going to stand for. It's the squares that are partially outside the figure. So this one would not count, but this one would. And then what we're going to do is we're going to take half of all of those boundary squares. And so what we're going to do is we're just going to accept that some of them are going to barely have any of the island in it, and some are going to have more than half or be almost completely full. Like this one's more than half. And so instead of estimating and calling this 0.6 and calling this one 0.4, because the more of those you have, that just gets to be a lot of extra work and you're not even being exact. So what's the point? So what we're going to do, if you take a look at the formula we're going to use, I is the inside ones. We're going to add that to half of the boundary ones. Okay, so we're going to add up all the boundary ones, and then we're just going to take half of that number. Basically, averaging them out and saying, on average, half of the square is taken up. Now, obviously, that's not true all the time, but sometimes it's less, sometimes it's more, sometimes it's right about half. But on average, if we take all of these boundary squares, they're about half full of the island, okay, or whatever we're trying to estimate. And that's not a perfect way to do it, but it's just a fast way that gets you kind of close, because no matter what we're estimating here. So what's the point of getting crazy with it if it's an estimate? No matter what, it's not a perfect science. It's not going to give us an exact number. So let's do this quickly and efficiently and get pretty close. Okay, it's not going to be that far off. But it's not also going to take forever to try and figure out each and every square. So we're basically taking half of those and then times u, which is the area of one square. So we're going to figure out with this combination, all the full squares plus half of the boundary squares, what's our total number of squares that we have in that picture. And then each square is going to be worth a certain amount of square miles. And so once we know how many squares the island is taking up in that picture, we'll multiply it times whatever the area of one square is to get the total area in the picture. Okay, so I basically explained what these directions here say. We're going to count the squares on the inside. We're going to count the ones that are partially outside. We're going to call those B for boundary. We'll figure out what's the area of a square, and then we will run that formula all the way through. Okay, so I need my inside. I'm going to take half of the boundary ones, and I'm going to times that by u, which is the area of one square. Let's start there. So this scale isn't lined up perfectly with one of these squares. Sometimes it will be given to you and you don't have to do any kind of figuring it out. But in this case, if you kind of slid this over, the length of one of these sides looks to be 8 miles. So we're just going to go with that. So 8 miles by 8 miles. So this full square here represents 8 by 8. We talked about in 8.2 it's just length times width, base times height, side times side for a square. So 8 times 8 is 64. So this one that we have here is going to be 64 square miles. Now that number 64 goes in for U. U is the area. If you forget, it's always up here. Area of one of the squares. So every square in this picture represents an 8 by 8 square, 64 square miles. So U is going to be 64. The total number of squares that are inside, they've done the shading here for you, is just 1. And then we need to count up how many boundary squares there are. So remember, this wouldn't count, and this one wouldn't count. Those are opposites. This doesn't have any part of the island. This entire square is part of the island, but we're going to do this one, this one, this one. I'm going to mark all of them that have some part of the island in their square. And as these get smaller and smaller, it's very easy to lose count. This is a pretty straightforward one, but when we get on the back, I do recommend that you mark all of them so you know which ones you've counted and which ones you haven't. It just makes it easier. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're going to take half. Be careful. The mistake when you go too fast is you just put 11 there. And that means you're counting 11 full squares if we don't take half. And obviously, we don't have 11 full squares. We have 11 partial squares, which are called your boundary. And so we need to go ahead and multiply. This is not 11 and a half. Don't add them together. It is 1/2 times 11. So half of 11 is 5.5. I highly suggest here in your notes you show every single step. So when you look back, you're not confused. But obviously, when you're going through this and you're understanding what you're doing, you can just do 11 times 1/2, take half of it, add the 1, and you quickly get your number here of 6.5. So 6.5 represents our estimate of total boxes that we have. So we have one full one, and then we've got 11 halves. So if we add up those 11 halves, it comes out to about 5.5. And we add it to the one whole one that we got. We have about 6.5 boxes that are taken up by the island in this picture. Each box is worth 64 square miles. So if we want to find out the area of this island, we're just going to do 6.5 times 64. And that comes out to 416 square miles. All right, so now we're going to go through the same process, but with smaller squares, and we're going to take note of how this number changes along the way, and we'll kind of make an inference based on that information on which one's more accurate. So we go to the back. On this one, let's start off with our formula every single time. So inside half of your boundaries times your area. Let's start with our area. One of these boxes now looks to be about 4 long on the side, right? From here to here looks about what this is on the side of a square. So they're about 4 by 4. 4 times 4 is 16 square miles. So the area of one square is 16 square miles. That's what goes in for you. Notice the size of the island hasn't changed, but the size of the boxes have. So each box is worth less in terms of the area. On the front, every single box was worth 64, and on the back, every single box is worth 16. So we're going to have more boxes, but each one is worth less. Let's see what we got. The smaller we make the boxes, the more of them fit inside completely. And we know that those actually are full 16 square mile boxes, where again, the other ones we have to estimate. So I have 5, 6 full boxes, and there's no estimating. I can be exact about that. The area of those boxes would be 6 times 16 square miles, and I know those exactly. The rest of these are like a quarter, or look at this one. This one's almost full. And that's why we average it, because we have ones that barely have anything, like this one. Like there's barely any part of the island in that one. And then we have ones like this one that almost the entire thing's full. And that's why we just take half of them, because if we take this and we average it out, each one of these boundary boxes is about half full. It's not perfect, again, but it's just efficient and it gets us pretty close. We're just estimating here. All right, so let's count up our boundary boxes. First, I think it helps to mark them all because it's very easy to miss them, I have found. So just a tip, you have different colors, it's nice to do this. And notice that I'm just going in a row. It's really easy to just miss one. We're not going to count that little one right there. And again, this is estimating, so all of you may count boxes slightly different. So we're not going to have exact answers. When you get to your homework on this, it's going to say answers may vary, meaning yours doesn't have to be exactly the same as theirs. We're estimating. And so if like you counted this box and the book didn't count that box, your answers will be slightly off, but your answer should be close. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 25. Okay, now remember, those don't count as 25 full boxes because they're not full. So it's going to be 1/2 times 25. That's important. So I'm going to show every step here. 6, and this should be plus, right? Be careful. 6 plus 6 full boxes plus 25 half boxes, basically. So 25 times half is 12.5. We're going to add those together. That's 18.5. And we're going to times that by what each box is worth. So there's 18 and a half boxes we're estimating that are made up of this island. Each one's worth 16 square miles. So we go ahead and we multiply those together, and it's 296 square miles. Now, think about that number here for a second. 296. On the front, we said 416. The size of this hasn't changed, but our estimate of how big that area is drastically different with the smaller squares compared to the bigger squares. Which one you think is more accurate? And the truth is, it's the smaller squares, and we'll see the smaller we get, this number slowly starts to decrease even more and more as we get closer to the actual number. So we have more full boxes. That's part of the reason we're more exact. And then on the front, we have these boxes that are worth 64 square miles that we're counting as our partials. Where here, these boxes that we're counting as our partials are only 16. And so the variance there is just not going to produce as much craziness the smaller and smaller we get. All right, so let's take a look at the next one. Again, the area of these is going to equal our boxes on the inside plus half of our boundaries times u. Now when we look at these squares, it looks like it's about 2 on each side. So these are 2 by 2, which means the area of each individual box now is just 4 square miles. Okay. You would count up all of your inside boxes. I suggest that you mark them. Especially when we get down here, you may want to use this strategy, but you could box off instead of counting each individual one, the bigger groups, and then it's just length times width for those boxes. So 1, 2, 3, 4 on the top here. 1, 2, 3, 4, 5, 6. So 6 times 4, I've got 24 total in this section, right? And then count outside that section. That may speed things up for you, especially when you get to these really tiny ones. So you can use that strategy, but obviously you can just count each and every box as well. So when I counted these all up on the inside, I got 49 of those. For the sake of time and you not having to sit here and listen to me count, I've got this already done, and you can just put this down. And then for our boundaries, remember, we want to make sure we're counting every single one. So you've got this one and this one and this one and this one. So I'm not going to go through the whole process here, but I am going to show you some of it. I suggest you go line by line like this so you don't miss any. This one's up to you whether you count that. I'll count that one. I got this one straight across. I got this one, this one, this one. And so going all the way around your boundary, you got to make sure you count every box. It's easy to miss one. So you go all the way through. When I did this, I ended up with 47 when I counted them. And again, some of these, like this one right here, where it looks like it just creeps in there, maybe you count it, maybe you don't. So we will be slightly off sometimes from each other and from the book. And again, that's why it says answers may vary. So when you are working in the book or on the worksheet, if your answer is very close, but just slightly off, that's okay. But it should be close. If you're way off, like we got 296 here, if you got 700 or you got 100, something's wrong. But if you got 300 or 289, right, that's close enough. We're estimating, that's perfectly fine. All right, so we have to take half of 47. Make sure you multiply. Don't do 47 and a half. It's 47 times a half because those are 47 half-filled boxes. So we're going to count those as 23.5 boxes. We have 49 full boxes. You're going to add those together. That's 72.5 boxes we're estimating. And each one of those boxes is worth 4 square miles. We go ahead, we multiply those together, and that comes out to 290 square miles. So these two came out very close compared to the one on the front, but we are getting a little more exact. We're kind of grinding this down. And when we get to this bottom one, we're going to be the most exact out of all of them. Because if you think about it, all of these are full boxes and we're not estimating. So what makes these closer and closer to the actual number is less and less estimating and guesswork. So the more full boxes that we have, the closer we are to the actual area. And the only little bit that we're going to be off are these ones that we're estimating, and we're just calling them 0.5 or half a box, which obviously is not perfect. So that's why we're a little bit off. But the more full boxes we have, the more exact we are, and then the smaller this number here is going to get. So for this one, I already went through and spent the time to count every single one. Again, you could go like this and create some big rectangles along the way, and then just multiply the length times the width, and you've got those, and then count everything else. I think that will speed things up if you had one like this. But I counted 245 full boxes for the inside. Let's write the formula down. Inside plus half of the boundaries times u. Okay, I counted 77 boundary ones. So there's not as many here. We're counting just these ones along the outside that are partially filled. And we're going to count those as half a box. So we'll take half of 77, which is 38.5. We'll multiply that times u. So 245 full boxes, 77 half boxes. So we'll count those as 38.5. So total number of boxes here. Let's grab that number. 245 plus 38.5. So 283.5 in here. And we have to times that by u. And now it looks to be that just one, so on the scale, just one tick mark, which does represent 1, is about how wide these boxes are. So these boxes are 1 by 1. So area is just length times width. 1 times 1 means each one is worth 1 square mile. So I'm estimating that there's 283.5 boxes that include the island. Each one's just worth 1 square mile. So when I multiply that, my final answer for the island is 283.5 square miles, which again, you'll notice is a little bit smaller and a little bit closer to the exact number. So the biggest concept I need you to grab is one, why this equation is working, and what we're doing is we're taking half of the boundary ones as an estimate, but we need to understand that the smaller the boxes, the smaller the grid, the more accurate our estimate becomes.